Hello everybody, welcome back to the shop. Today I'm going to be showing you how to make a hot tube burner. I got a second hot tube engine. It's a half-breed, a Ajax Ball half-breed. Some videos of that will be coming soon. Stay tuned. Hit the subscribe button so you can stay up to date with videos of that engine. But it's a running engine, but didn't come with a torch or it didn't come with a burner, so we're going to make one. It's super simple. I'm going to show you how to do it. These are the basic ingredients: 1/4 inch street elbow, 1/8 inch NPT plug. This is brass. I chose brass rather than steel because this part is going to be getting hot. This is going to be part of the nozzle. So just for anti-seizing purposes I chose brass. Piece of 3/8 pipe and a piece of 1/2 inch pipe. So the first thing we're going to do is take this 1/4 inch NPT street elbow and on the male end drill it out for the tap drill size of an 1/8 inch NPT thread. The tap drill is an R drill. And take a tap, 1/8 inch NPT tap, a little bit of oil, and get that as centered as you can. There's aligned. This cuts really nice and easy since I believe this is cast iron or cast steel or something. It makes a real fine chip. It cuts nice. You hardly even need to back off to break a chip because the chips break themselves pretty easily. Okay, so here's the finished product. That plug threads in there just about halfway, which is good. So we'll set this aside. Now we're going to make a 1/4 inch to 3/8 bushing out of this piece of 3/8 pipe. I have it threaded into another fitting just so I can hold it. I need to hold on to the threads, and I'm going to cut this piece of pipe right at the end of the threads there. Alright, so that 3/8 piece of pipe is cut off, deburred it a little bit. Now I'm going to tap a 1/4 inch NPT hole, or a 1/4 inch NPT thread on the inside of this pipe. And this thread I'm going to thread deep because I want this 1/4 inch street elbow to pretty much thread all the way into the end of the threads. We're not concerned with sealing, we're just concerned with mechanical fastening, really. Alright, here's the finished bushing. See, it threads on there all the way. It just starts to get tight when we're at our last threads. That's just right. Next up, got our piece of 1/2 inch pipe in the vise. We're going to thread the ID of this piece of pipe with 3/8 NPT. And once again, I'm going to thread this deep. We're not concerned with sealing here either, just fastening. So I'm going to thread it the same way like I did this. So I want this 1/2 inch pipe to bottom out pretty much at the same location right there. Alright, there we go. I got the threads on the ID of that 1/2 inch pipe. And you can see once I spin it on, it stops right where I want it. So the next step, what we're going to do, place these side by side like that, and with a Sharpie I'm going to mark roughly on the pipe, on the 1/2 inch pipe, where these if this was threaded all the way in, if these two surfaces are even, I'm going to mark right where the threads end there on the pipe. So what we're going to do now is cut the air slot. The because when the gas is flowing through this jet, or what will soon be a jet or nozzle, it's going to pull air in via a Venturi action through some air slots. So the air slot is going to start here, and I'll choose a spot, I think about here, something like that. It's going to be that wide, and the slots are going to take up the majority of the pipe. I'm going to be removing the majority of the pipe. A window will be there, and then on the other side I'll have a cutout over here. So the parts I scribbled out, if this is going to be cut out, I'll have just a little web on this side and a little web on the other side holding it together, roughly this wide. This is maybe a 1/4 inch or so. Alright, so here's the Venturi part that I have viced up, clamped up in the Bridgeport. I could have just cut this slot with an angle grinder and a little bit of time, but I have the milling machine at my disposal, so might as well do that. It's been quite a number of years since I used the Bridgeport, but still know how to make chips. Fake it till you make it. So now I'm going to make the jet itself, the gas jet. And what I've used is a MIG welding tip. I think this is an 030 MIG welding tip, but the hole in the middle is just a little bit too big. So what I did, might be a little hard to see, but I took a ball bearing, not like a 3/16 or 1/4 inch, maybe 3/16 ball bearing, rested it on the very tip of this in the hole, and setting this up vertically, I used the hydraulic press to gently touch and push that ball into the tip of this MIG welding tip, and that deforms the material and pushes some of it into the hole, and in effect makes that hole smaller. You'll have to experiment a couple times and use some gauge pins to determine the actual ID that you make when you press that ball bearing in there. Or you could use something totally different. You could machine this, or you just use a real skinny drill bit, whatever. But this is what I thought would work well. And then in this brass plug here, I'm going to drill and tap a hole that'll accept this. Now this is it's a goofy thread. It's what I think is 1/4 24, and the standard 1/4 inch threads are 1/4 20 and 1/4 28. So I'm going to tap a 1/4 20 hole. It works okay. You just jam it in as far as you can with some pipe dope, and it seals up fine. This is only going to be seeing 11 inches water column pressure, so it won't take very much to seal it. Alright, so I got the hole drilled. Now you'll note I have it in this, this is a bushing, a 1/8 to 1/4 bushing. This is how I drilled it. This is how I held it to drill it, because of course you don't want to clamp on the threads themselves, you'll ruin the threads. So I just found a convenient fitting that I could clamp to. So I have a 1/4 20 thread tap, a little bit of lubrication, and we'll send it in. Hold it nice and steady and vertical. Okay, so I got this all set up on my Ajax half-breed. Threaded everything together. I put in a nozzle that is, I believe, 035 hole diameter. I made this little choke. Sometimes you need this choke depending on the weather or depending on any variety of things. Just a can that I cut into a strip. You can slide it over or pull it away as you need. I have a valve. This is a gate valve. You can use a needle valve, whatever. Just something to throttle the flow if you need to. Have it hooked up to a propane tank. This is a barbecue regulator or a camper regulator, something like that. 11-inch water column pressure. Let's see how it works. There you have it. The flame is kind of noisy. I don't know why some burners I see are nice and quiet. Most of them I see are nice and quiet. And this one isn't. Honestly, I'm really not sure why. I would like to make it quieter. If anybody has any suggestions, give me a shout. Like I said, I think I've said before, a lot of people like to use high pressure, just like 10 psi, 5 psi, rather than 11 inches of water column. I've tried both. I've had better luck with low pressure. But I'm going to let this burn for a while and see how it heats up the tube. Well, the burner's been burning for about 5 or 10 minutes. And, well, I'm going to shut it off so maybe you can see how hot it is. It's definitely glowing. The whole tube is nice and hot, so it works pretty well. The one thing I don't like is that loud noise it makes when it's burning. I've seen a lot of burners where it's just a nice, even, quiet hiss like a gas stove. So I'm still trying to figure that out. If you choke the air off a lot, it quiets down, but then if you choke it off too much, the flame goes rich and yellow rather than blue, and it'll burn cold. But does seem to work pretty well, and maybe if I play with the gas jet, that'll help the noise situation. I do notice if you look down in the tube, the flame starts burning like here rather than over here, and I don't know if that's an issue. That might be part of why it's making noise. Jet diameter and gas pressure probably will have an effect on that, but it works pretty well. So I'll see if I can get this engine running for our fall show at the Zachary Farm Museum. So I hope this helps out some of you guys that are making your own burners for hot tube engines. Thanks for watching. Make sure to hit the subscribe button down below, the like button if you enjoyed this. And also down in the description there's a Patreon account if you want to donate money to the Beer and Engine Fund, and there's also an email where you can donate through PayPal if you feel so inclined. I appreciate it. It helps me keep the wheels oiled and greased. So thanks for watching, everybody, and stay tuned for more.